So we have, looks like we have better participation in the afternoon, doesn't it? One of the things I've found out is that it takes me a really long time to put stuff together for you guys. And so, I don't know, meeting in the afternoon is better. So, yeah. Here's what I want to do today. I want to go over with you guys. Let's see here. I want to go over with you guys today. Oh, man. Wow, look at that. Need a haircut bad. Look at that beard. Wow. That's epic. I got my Mr. Rogers shirt on today and everything. So what I want to do today with you guys is go over some trig stuff. I got a lot of you guys have finished the quiz already, which is excellent. Hey, Danitza. I want to go over some of the basics. I also want to show you guys how to use a calculator, because a lot of you guys said you had trouble using the calculator to get the answers. Like when you went over it, you saw that you were setting up the equations right, but you're having trouble with the calculator. I also wanted to show you how you can use your calculator on your phone. It's different. Like the way you type in the numbers is different. So it's something I know you guys could, yeah, it's not too tricky. It's not too tricky. So let me see. Before we go ahead and get started, we've got Oreo's here. Man, dang, Oreo. Man, most of you guys still. Let's see, Atticus and Alfredo followed instructions. Oh, yeah. Alfredo's question is the calculator, is it in radians or degrees? Needs to be in degrees for what we're doing right now. We'll do radians later. But for right now, just degrees. Let's see. Who else is here? Danitza's here. Alexa, Alfredo, Atticus, Danitza, Davy Boy, and Oreo. Dang. The Who's Who crew. Right? All right. So let's see here. Let's see how we can get you guys set up. Let me go ahead and pull up the stuff we've been working on. Trigonometry. And let's see. Solving right triangles. Out of you guys, how many of you have taken the quiz so far? You can just leave me, you can tell me in the chat right there. I'm gonna look it up right now real quick though. Let's see. Drive. So I'm looking it up. Solving right triangles. It looks like only six of you have responded. Okay, hold on. Let me check. I want to make sure I have a setting right real quick. Okay. See summary charts. Yeah. Okay, we're good. All right, so just 6 of you. It looks like the average score is just a little under 7 out of 14, so that's pretty rough. That tells me that this is a difficult topic. Yeah. All right, that's all right though. That's what we're gonna go over today. All right, let me get back to. I have too many windows open. Here we go. Yeah. All right. So let's go over the document camera over here. Let me get it started. Alfredo, how was that quiz for you? I mean, I see your score. I'm not going to say it because that's private information. But how was it? Was it like, were you surprised how you did? Some non-smart mistakes. And then after you submitted it, did you see there's like, I don't know, there's like notes or sometimes like text or videos. Did you see all that? And then the second question is, did you use it? Did it help? Because I know that's like one of the biggest issues that we're having. Okay, you watched them before. There were some in there that you couldn't have watched before, though, because there were some questions in there that, well, maybe you did because they were posted, but yeah, okay. But so like one of the biggest issues that we're having, like you guys and me, is learning math in this kind of setting is really tricky. because the most important part of learning math happens when you get information and you have enough information and ability to like carry out some steps, but you get stuck and confused. It's at that point where you get confused. From there forward is where the real learning starts to happen. And it's hard to facilitate that learning in this kind of environment. So, man, I'm not really sure how to go about it. I know that this part can be a key component of it, and I haven't done a very good job of it. So I got to pick up my end of the game on this part. But one thing I have done is on those Google quizzes, I'm putting that information in there, and I think it can be helpful. That's my hope. Is that like when you miss one, you can read about what it is that you did wrong, or or whatever's there. And still, you guys emailing me, putting private messages when you turn in stuff that gives me an idea of what you guys need help with. And yeah, so it's a good start. Okay, let's go ahead and start doing some practice questions right here. Let's switch over. All right, so you guys all see the screen right there? You can tell me in the chat room if you do, or if you don't. So I'm gonna go ahead and start. We're gonna draw a beautiful thing right here, shall we? Let's draw some random triangle. Hashtag not to scale. Whoa. Not to scale. So take notes. Don't just observe. Go ahead and take notes, because there's going to be some new information. Good. There's going to be some new information I'm going to share with you guys today that I know we're going to learn it later, but sometimes seeing it as it just comes up naturally is a good idea. Okay. So, and I will post this so you guys can watch it later. Anybody that's not here can watch it later. And when we go back to school next year, you guys should bring me cookies. All right, so look, check it out. Here's what I wanted to show you guys about this. One of the things there's this theorem called the Triangle Inequality Theorem, right? It's actually written out in words most of the time. Basically, what the Triangle Inequality Theorem is saying is that the smallest angle is opposite of the shortest side. It kind of seems obvious, but it's easy to mix it up too. So this is obviously the shortest side. It's definitely shorter than this side. That means this angle, which is opposite of it, is going to be smaller than this angle. Okay, and so that's something you just kind of have to keep in the back of your mind sometimes. I'm not going to give you, usually you're not going to get a quiz question on that or anything, but if I gave you this triangle and I said, hey, this is a 30, 60, 90 right triangle, and I said this was A and this was B, could you guys tell me which side would be 30, or which angle would be 30, A or B? You can put your answer in the chat if you like. I'll give you a second to think about it. So go ahead. So in the chat. So here, we're going to start a hashtag. Oh, man. In the chat, right? Which angle is A? 30, 60, or 90? Number 30. A is 30. Yeah, A is 30. Number. Atticus. Why did you type? Oh, I see. Yeah. A is 30. Okay. Which angle's angle A? 30. Yeah. Or I guess that's not even said right there, right? It says like how many degrees, or what's the measure, right? Okay. How many degrees is angle A? Oh man, English is hard. Oh, I got it. Hashtag got it. Okay. So A is 30 for sure. It's the smallest. Okay. So now, what if they told you, and this is where it's going to get a little tricky, right? What if this was 5 times the square root of 6? Dang. Man. Could you figure out A and C? So let's see. Man, I'm going to help you guys out on this one, okay? I'm going to help you guys out on this one right now. Check this out. Here's the thing I also want you to be aware of. is, like in trig, especially in Cambridge, they have a certain style of way they label things. So lowercase letters are usually angles and uppercase letters are usually sides. And what you're going to end up seeing is you're going to end up seeing stuff like formulas like this. You're going to have like A over this. Oh, yeah, sure, Eddie. What you're going to end up having is A over the sine of A equals B over the sine of B. That's a formula you don't know yet, but there's a relationship between the lowercase and the uppercase letter. And it doesn't really matter which one's which, right? For sine, the input is always an angle, right? And so they could do it this way sometimes. There's not like a hard and fast rule about it, but the thing I want you to recognize is the lowercase and uppercase letters are related sides on a triangle. So like the way it's written here, A is an angle, and lowercase a is the opposite side. Okay? There. I don't know if you guys could see that part. All right. So like, for example, that's why this lowercase a and that uppercase a are opposite of each other. So that's not on accident. That's on purpose. That's just one of the things you're going to have to learn how to read when you look at a diagram. Okay. So now let's see if we can figure this out. We can do it without trigonometry, actually, because what we know is if this is a 30, 60, 90 right triangle, we know that A is half of C, right? So I know that A equals 1/2 of C. I also know that this side, 5√6, is equal to A times the square root of 3. You follow me? Do you see what I mean? So just setting up that basic thing right there is how you're going to figure this out. So let's see here. Whatever A is, this long side is the short side times the square root of 3. So if we wrote that out in words, this is only for a 30, 60, 90, right? So the long side equals the short side times the square root of 3. Now, so I happen to know what the long side is. Look, this is right here. Look, right there. That's the formula right there. Look at that. Man, that's hotness. This is hot. All right, so long side. I think I've been in quarantine too long. I'm losing my mind. Let's say A times the square root of 3. So all you got to do is solve that, you see? So the leap of faith is you're not really sure how to make sense of this information. And so then so that's the observation. So the leap of faith is what do you know that could make use of this information? This is what you're given and this is what you need. So you need some sort of relationship between the two. Because it's a 30, 60, 90, we can do that. Okay, so all you gotta do is divide, right? Both sides by √3. And then you've got 5√2. Okay, so A would be 5√2. All right, before we move on, this is where it's really tricky teaching like this. Before we move on, I want to check in, see how you guys are doing with that. I wish I could think. I can't think of a question to ask you that I could check for your understanding, like in this format. So this is really tricky, man. Tell you what, if you do have a question about that, just ask me. Like, it can be anything about this so far. I'll give you give you a little bit to think about it. And of course, if you ask about one later, or if you ask about this thing later, that's fine. We can go back. Eddie, we're kind of reviewing. Excuse me. We're reviewing some of the stuff that people had trouble with trig. Only 6 people have taken the quiz so far, and so we're kind of talking about that too, solving right triangles using trigonometry. All right. Well, if we wanted to figure out C, we know this is half of C, right? So that means that C would have to be 10√2. Yeah. I'm slightly confused on how the short side was found. Okay. Alfredo, here's what I know. I know for a 30, 60, 90 that the long side is equal to the short side times the square root of 3. That's always true. This is always true for a 30, 60, 90. Like forever and ever, amen. That is always true, 100%. I happen to know what the long side is. It's 5 times the square root of 6. I don't know what the short side is, so I'm going to call it A. I'm going to multiply it by the square root of 3 because that's the relationship. And you just solve for A. Divided both sides by the square root of 3, and then we're good. It's kind of a weird thing, right? Yeah, okay. Okay. Yeah. Okay, so that only works for a 30, 60, 90. Now, one of the things I also wanted to do with this right here is I wanted to help you guys just refresh your memory on how all of these radicals and square roots and things work. So here's what I want to try. Let's use the Pythagorean Theorem to see if this is really a right triangle or not, okay? So the Pythagorean Theorem, a squared plus b squared equals c squared. So there's a squared. Here, let me move the paper up for you. Sorry about that. There's a squared. Here's b squared. Here's c squared. Let's see if this really works, right? So here's what I'll do. I'm going to figure out this one. I want you guys in the comment. I want you to tell me, what does 5 root 6 squared equal? All right. If you're not sure, I'll go ahead and do this one right here. This one is 25 times the square root of 2 squared is 2. So that's 50 equals 200. Well, I sure hope it equals 150. Because if it doesn't, we're in trouble. You guys try it. See if it does. See if it equals 150. Yeah. Are you sure? You good with that, Alfredo? Yeah, because here you go. 5 root 6, right? Times 5 root 6. Well, you can change the order when you multiply. So you could do it like this. 5 times 5 times the square root of 6 times the square root of 6. So that's 5 times the square root of 36. It's 5 times 6. Oh, no. 25. 25 times 6. It's 150. Yeah. Use the calculator. No calculator. Man, you got to be able to do this on paper, very seriously. It's okay you got it on your calculator, but you got to be able to do these things on paper for sure. You'll be taking quizzes with trig, no calculator, and that's probably some of the trickiest stuff you're going to have to do. It's trigonometry without a calculator. But it's really important that you can do it, because if you can do it, then you understand the properties and values of trig, and you understand what trigonometry is, and then you can build upon it. I know, I get it. It's all right. I'm not trying to bust your chops too much, Alfredo. You're my favorite Alfredo. How can I be mad at you? Besides, use the force, right? All right. So next thing I wanted to help you guys out with, just based on what you guys were telling me, right, is, let's say, oh man, let's say we have some random triangle, hashtag not to scale, yeah? And let's say, let's say that this is angle A right here. And let's say we were told that tangent of A equaled 7/8. Yeah? And then let's say we were asked to figure out how long is the hypotenuse. I know you guys are having trouble with this kind of question, and a calculator probably won't really handle that for you. You could actually use a calculator to figure this out, but it would be a lot of work. Whereas if you recognize the importance or the meaning of what the tangent of A is really telling you, then it's going to be super, super easy. Anybody have an idea? So in the comments, do you have an idea how to start? Anybody? Oh, whoops, what? Oh, 14. Oh, okay. No, not 14. Sorry. Yeah. Anybody got an idea how to start this? Oops, I lost the chat there. But yeah, but how? How do you get 1109? How'd you get that, Davy boy? You can turn on your microphone if you want. You don't have to. Because I think it would be hard to type. Yeah, tell us.
Tangent of A, it
Yeah?
would be opposite over adjacent. And so I know that for A, the opposite is on the left side. That one would be 7. And on the bottom, it would be 8. And then I just do Pythagorean Theorem.
Dang, bruh. Man, killing it, son. So that's 49 plus 64, and the square root of that, whatever it is, right? Man, there you go. That's pretty good. Man, thank you, Davy boy. Man, if you were here in person, if we were in person and I had a goldfish cracker, I'd give you a goldfish cracker. But we'll have to settle for a virtual one. Okay, now I do have a little bit of a problem though. I didn't get, you wrote 10.9. I know, Alfredo, I'm sorry, buddy. You wrote 10.9 and I didn't get 10.9. So I'm just going to make sure. So this is a good idea to do on a quiz or a test if you're ever not sure about your answer, right? Just do it again and maybe type the numbers in a little different. So here's what I'm going to do. I'm going to do the square root of 7 squared plus 8 squared. I'm going to close the parentheses. Yeah, I think it's 10.6 or 10.63. Yeah. Now there's this thing called significant figures. So check this out. We're going to say 10.6. Let's see. Significant figures. It's kind of like rounding, except instead of starting at the decimal, you start at the left and you count to the right. So this right here is 3 figures. This right here is 3 figures. And in Cambridge math, 99.9% of the time, they want 3 significant figures. And for some reason, that's really hard for people to get straight in their head. But it's something we're really going to have to focus on. Man, I can't put all these kinds of little tidbits in videos because then they get too bogged down. It gets a little too confusing. That's why live is better. Davey boy, that's right. I forgive you. You still did excellent. You know what? This is actually, it's interesting. So this is really interesting too. So Davey boy got this wrong, but he had the right idea. And so if he was taking a quiz and he wrote this, let's say this was a 3-point problem, I'd give him at least 2 points. I may give him full credit. But when you take the quizzes online, he's going to get 0. And so that kind of sucks. So that's one of the things I got to keep in mind when I'm grading your stuff is how to give you partial credit and give you the benefit of the doubt and stuff. Because it's hard for you to show me your work and all that kind of thing. All right. So you guys are good there. All right. Could you, okay, so let's say the same thing, right? Let's say we're going to have that same triangle. So not to scale again, right? But let's say this is angle A. And let's say it said the tangent of A equals 7/8. Now, different instructions this time. What if it said to solve the triangle? Well, first of all, solving the triangle means you need to figure out what this angle is, what this side and this side and this side are. Do you see? That's what solving the triangle means. So we already know from the last example, we already know because tangent of 7/8 means this is 7 and that's 8. And we figured out this was 10.6. All we got to do is figure out the angle. All right. Let's see, Alfredo, your question is, how do you make your calculator solve unperfect square roots? So if you put in like so let me see, Alfredo. So if you put in the square root of 3, it doesn't tell you it's like, I don't know, 1.7 or something. So like square root of 3, it doesn't do that. It just leaves it square root of 3. Because if that's the case, there's a setting. It depends on the model of calculator you're using, but there's a setting where you can change it to do approximations. Yeah, and I'm not really sure. It depends on the type of calculator you're using. It's probably a Casio, and I don't really know how those work, but it should be easy to figure out if you just Google it. I wish I could give you a direct answer, but I don't know. Yeah, but it shouldn't be too bad. It should be pretty easy to fix. All right. Yeah, thanks for asking, Alfredo. No problems. I say thank you for asking because literally, and one of the things I miss most about teaching is just the interaction and when you guys ask me questions, and I don't know, it's something I miss quite a bit. So, all right, let's do this. Tangent of A. So first of all, this is a function, right? And this is the input, and this is the output. You cannot use inverse operations to solve for A. So, whoa, cannot, here, I'll fix it. We'll make it mathy. Check this out. You cannot use SADMAP to solve this for A. You can't use you can't use inverse operations to solve that for A because A is the input. You found it? Good. I'm glad you got it, Alfredo. So we can't use inverse operations. So what we have to do is we have to use inverse functions. So inverse functions, if you remember, they exchange the input and the output. So the symbol on your calculator is that inverse thing. And here's how you say it: arctangent. Oops. Arctangent. And so what arctangent does is it swaps the input and output. So you know that regular tangent has an input that's an angle and an output that's a ratio of sides. Right? So here you have an angle. Whoa. And here you have a ratio of sides, right? Well, so for the inverse function, it's swapped. So the input becomes the ratio of sides, and the output becomes the angle. You see, they switch. And so if you did that for this, if you use arctangent for this, the input and output get switched. So you would say that the arctangent of 7/8 equals A. Here the input's the ratio, the output's the side of the angle, and so you can use a calculator for that. If you look at sine, cosine, and tangent on your calculator, above tangent is, I have a really crappy document camera, and I don't know, there you can see it, I think. See, it says tan to the power of -1. Here's the other thing. This -1, once again, that's not an exponent. That means inverse. Like here, if you had 5x to the power of -1, that would be 1 over 5x. So that's confusing because contextually they're different, even though they look identical. Contextually, this is a negative exponent, and this means inverse function. So that's really can be a confusing thing. But this doesn't mean 1 over tangent. It's not what it means. It's not a reciprocal function. It's an inverse function. So anyway, arctangent of 7/8. So second, and then tangent. So see arctangent, and then 7 divided by 8. Looks like that's about a 41.2 degree angle. 41.2 degrees. So then to figure out the other one, you just subtract 90 from that. 90, oops, minus your answer. You could probably do that in your head anyway, 48.8. And then you're good to go. So that's how you solve a triangle using, well, that was using tangent, right? Let's do one more example, okay? Let's do one more example where, let's say you have a one angle and one side, and you're being asked to find the other sides and the other angle, okay? So again, once again, not to scale, right? Take notes, try this together with us, right? Let's say that we knew this was 15.2 centimeters or something like that. And let's say this was 28 degrees. Yeah. And we had to solve this triangle. All right. Well, here's what I would do. You see this side right here? That's to this angle, it's adjacent. and to this side over here is opposite, right? And this angle is easy to figure out, so it's going to be minus 90 is going to be 62, I hope. Yeah, 62. Oh, Atticus left and came back. So, Danitza, here's what I'd say. Check us out, Danitza. We weren't given this. We figured it out, so I wouldn't use it. I would use this because this is what we were given. Because if we made a mistake with that, oh, that's fine. Don't worry about it, Atticus. I was just giving you a hard time. So if we made a mistake here, and it's really easy to do a subtraction error, it happens all the time. If we made a mistake here and we use that value, everything's going to be wrong. So let's use this value. All right. Now, here's what I know. I know that the cosine of 28 degrees is going to be adjacent over hypotenuse. Hypotenuse is 15.2. Do you see? And I also know that sine of 28 degrees is going to be the opposite over the hypotenuse. So all you got to do is your formula, right? And then you just solve it. So it's easy. It's really easy when the unknown is in the numerator. It's really, really easy when the unknown's in the numerator. So then when that's the case, all you got to do is just one step, multiply both sides by 15.2, plug it into your calculator, and you're good, right? So 15.2 times cosine of 28, 13.4. So the adjacent side was 13.4. Yeah, and that's rounded 3 significant figures correctly. Whereas this one, 15.2 times the sine of 28, that's going to give us 7.14. 7.14. There we go. So now let's say we wanted to use let's say we wanted to find this angle right here and we didn't know this angle. So let's say we had this triangle, right? And we wanted to find that angle. And so some of you guys had some questions about a calculator that was asking this kind of question. So if we know all 3 sides, we can do sine, cosine, or tangent. It won't really matter. So I'm just going to use sine. So sine of the question mark is opposite over hypotenuse. So this would be 13.4 divided by 15.2. So you can't use inverse operations again. What you have to do is inverse function. So second sine, 13.4 divided by 15.2, 61.8 degrees. That's what it would be. Yeah, so, and that's pretty close to what we found out anyway. I mean, makes sense, right? Because it was both ways, but yeah, so that's how you use your calculator. Now, if you use your calculator on your phone, a lot of the time, what you have to do is you have to put the number of the angle in first. So like, let me see if I can get this. Let me see if my calculator does it this way. I don't remember exactly. So for example, I know the sine of 30 degrees, and this is a good way to test, is 1/2. Okay, sine of 30 degrees is 1/2. It's just right. So I mean, you should memorize that. So 30, I think you type it in first. No, sometimes you do. Some calculators you type in the degree first, and then you hit the trig function. So that's how it is in my computer's calculator, but not here. All right. Well, how you guys doing? How about we do this? How about I give you a practice problem so you can try it, and I'll give you like 2 minutes, maybe 3, and then we'll come back and check on you, see how you did. We'll go over it, and then you should be ready to take your quiz, okay? All right, so let's say we had this triangle right here, and I want you to solve the triangle. It's a right angle. Let's say that this is 59 degrees, and let's say this is 11. So see if you can solve that. I'll be back in just a minute. You guys try that out. Silly dog. All right. Oh, I think on this one you had to use a calculator, Alfredo. How many guys got here? We'll do in the chat box. Number one. Let's say this is angle A equals. We'll say this is side B. And that's side C. So you guys can put your answers in the chat box right there when you get them. And then if you're totally stuck, you can just write stuck. We'll see if you can. Doesn't A equal 31? I don't know, does it? Yeah, A is 31 because, 90 minus 59, right? Yeah, right. 81 or 31. Good. Good. So I'll go ahead and write that up because you guys already said it. That symbol means angle, right? That's true. There's another way we could probably get that. No, we can't because we would need another side. Alfredo says B equals 18 point. Can you make that three significant figures? 18.3 would be three figures. Okay, three. Oh, Davey Boy's got this. And then he says 21.4. Let's find out. Ready? Okay, so I'm not sure how you guys did B, but for me, for B, I would say B is, I would use tangent because tangent of this opposite over adjacent. I think that's the easiest way. So I would say tangent of 59 degrees equals B over 11. And then, so yeah, you just do 11 times square root of 59, or square root. 11 times tangent of 59. Whoa. 11 times tangent of 59. I did art tangent for some reason. 18.31. Now, if it was three significant figures, it would just be 18.3. Significant figures are talking about how accurate your information is. And since we have two digits here, we're not going to be really accurate, to 17 digits or something like that. So usually we go to 3. Yeah, all that. So Alfredo's got this too. Okay. And then for C, well, like if we don't use this and we don't use this angle, right? Like if we only use this, we can still do it. It's tricky. I want to talk about it, right? Like, here's the easy way. Here's what I would do, but easy way, but it's maybe got some danger. Okay. Here's the easy way. The easy way to do this is to use the 31 degrees. And so if you use 31 degrees, you could do the sine of 31 degrees. Oh, wait a minute. No, that's not the easy way. The easy way would be, oh, wait a minute. Opposite over adjacent. I mean, opposite over hypotenuse. I was thinking like, never mind, because it's the hypotenuse. I take it back. Well, I guess no. I'll take it back. I'm sorry. Here's the easy way. And this is why you got to do crack after school, right? And for everybody that's going to watch this later, if they don't know that's like a standing joke, they might think, oh my gosh. So 121 plus, I don't know what 18.3 is, squared, 339, or 334.89. And then when you take the square root of that, $21.3. Good. 21.3. Now, there is another way to do it. And it involves this, also involves this new thing that you guys don't know about probably, called reciprocal functions. Reciprocal trig functions, that's where, like, so you know how tangent is opposite over adjacent? Well, the reciprocal function, not inverse, reciprocal, flips it over. So we could actually use that to figure out side C. So check this out. Let's say we were going to use, we're not going to use tangent. So let's say for this one right here, let's say we use 59 degrees. So 59 degrees is, let's see, cosine of 59 degrees is equal to 11 over C. Yeah, you follow me, right? Well, the reciprocal function of cosine is called secant. And I'll teach you all that later. I will. This is like a sneak preview, okay? We'll get into that pretty soon. They're called reciprocal functions. So this is kind of a sneak peek. The input's still the angle, right? But the output is the reciprocal. So here it's hypotenuse over adjacent. So 11 times secant of 59 degrees. Problem is, most calculators won't do it. Most calculators won't do that. So what secant is actually, it's reciprocal. So that's probably a little funky for you, I know. So 11 divided by cosine 59. Same thing though, see? 21.4. Oh, this was 3.9, so I should have rounded correctly. 21.4. So that's probably new for you guys, but there are these things called reciprocal functions. We're going to be learning about them in the future. So you guys need to get your quiz done. Yeah, let's see. Let me check Google Classroom. Oh, stop it. So here, let's see here. There we go. All right. There. All right, so we're back. Let me check Google Classroom, see what's coming up for you guys, just to make sure that I'm all aware of what your expectations are for the rest of this week. So it looks like due today is solving the right triangles, which you kind of went over. And then let's see. Boy, a lot of you didn't take the unit circle quiz. No, not that one. Let's see here. I know I just heard somebody chime in on the chat. What? So Atticus, I'm not sure. You might have. What kind of calculator are you using? Ah, yes. Hold on. So what I'm doing right now while I'm waiting for, what I'm going to do right now is I'm moving the unit circle thing up so that you've got your unit circle quiz due tomorrow. That's tricky, and try your best. Do well. 9 of you have done it so far. And then you've got the solving right triangles quiz due today, and 6 of you have done it. So if you haven't done those, you need to get on top of those. And that's all we really got until next week. Okay, so I'm not going to give you something new for tomorrow because I just want you to do that quiz. And then next week, we're going to start off with, I think we might actually be starting off, yeah, we are going to start off with the reciprocal trig functions next week. Oh, yeah, radians. So to change for radians to degrees, it depends on the calculator. Let's see here. There should be a mode button. And when you click it, you should have a whole bunch of options. So like there's a mode button. My mode button is right. That's probably really blurry, huh? So my mode button's right there. If you have a TI 30 series, which is what we use in school, it's almost in the same exact location. And so when you click mode, you're going to get this screen, and yours is going to be way smaller, but you're going to have somewhere on there radians and degrees. So you just have to toggle from one to the next. Okay, good. Got it. All right, ladies and gentlemen, I appreciate your efforts. You're doing really well. I do know this for sure. Those of you who are working consistently, your efforts really speak to the kind of person you are, to your character. I know that learning remotely can be really difficult and confusing, But if you can figure this out, if you can figure out how to do this, you're going to be rock solid. Yeah, Eddie, those are already there. They've been in Google Classroom all week. So the unit circle quiz kind of got dropped to the bottom, but I went ahead and bumped it up to the very top. So it's the second to the top thing. So the top list of classwork, the top thing on the list of classwork is the solving right triangles quiz. And then the other one is the unit circle. So after you do those quizzes and you submit it, go through your answers, because if you get it wrong, there's an explanation as to why the right answer is what it is. And maybe in some cases it'll like discuss what the pitfall was, because when I read a question, I know what people are often going to mistake and get wrong. So I tried to talk about that too. So it's all there.
Wait, I have a quick question.
Yeah, what's up?
On the first, I don't know. The first question on the quiz, just like an overall. How do I know where to put the A, B, and C? Because I put the A in the wrong spot, which ended up me trying to do the wrong angle.
So for number one, it says triangle ABC. Oh, well, it tells you. You have to figure out from reading it. It's a tricky thing.
And
I
then
understand.
It says B is 90 degrees, so I put that on the bottom left. And then I thought
Right.
ABC, so left to right. So I put A on top, but it was supposed to be on the right.
No, it could be either place, but what would matter is where the 8.4 goes and where the 12 goes.
Okay.
So if you put A on the top left, then the left side will be 12 and the bottom would be 8.4.
Mm-hmm.
That makes sense?
That's what I got, yeah.
Okay, yeah, that's fine. That's perfect. There's no problems there. Yeah. All right. And let's see. I don't know. Anybody else got anything going on? Nothing, huh? All right. Well, if you do, you can hit me up an email or send me a message on Google Classroom. I prefer email because Google Classroom, I don't know. It's the best we got, and sometimes it works pretty well, but like messages get lost. Like I'll get a message on my phone and then I go check on the computer. It's like totally gone. I cannot find it anywhere. And so it like eats them. So I'm sure it's something wrong on my end, but it doesn't matter. I'm losing them. So I don't want to do that. So email's better. But if it's attached to an assignment you're turning in, then it's no problem whatsoever. I don't lose those. It's just if you send me one out of nowhere, sometimes they disappear. But yeah. Draft is today. What's that mean? Oh, NFL draft. Oh, wow. Yeah. Weird. It's weird to think about sports. All right, guys. Well, I've got to get ready for my next class at 2:00. And so I'm going to sign off. And I will talk to you guys. Later. Hope you have a good day. Let me know how you did. If you have, after you do those quizzes, if you have confusion still, just send me, just let me know. And I'd be very happy to go over it with you or for you or whatever. All right. I'll talk to you guys later. Okay.
Bye-bye.
Hello there, David.